Physics students, oh boy, here we are, final exam review. We're almost done. I see lots of good work. I also see people who need to do some work. So keep up with this. Remember, final exam, important. I'm going to put it on Cast to Learn. Okay, and you know the deal with that. Okay, so here we go. Reference table, I think, is very important for this one because I just wouldn't want to memorize all these silly formulas. So I would like to have a reference table. So I have my reference table. I'll be referring to my reference table. That's a reference table. So let's get going. Let's get doing. Get a good job here. Remember, copy these down. Show me the work. Get credit. Boost your grade. Lots of 90s in my class. I want to see more 90s. And I want people really good averages. Okay. So it says, which graph best represents the relationship between photon energy and photon frequency? Well, a lot of our lists for this one, we're going to go to the modern physics section of the reference table, which is page 6, and it's in the middle. Okay, so the energy of a photon and the frequency. So frequency is F, energy is big E, energy of a photon, and I look at these two. It's one of those things where it's two different ones. Because frequency and wavelength are inverse to each other. Remember that, right? As frequency increases, wavelength decreases. As wavelength increases, frequency. As wavelength increases, frequency decreases. Okay? They're inversely proportional to each other. But in this case, we just need to look at this. E equals H times F. When I look at this, the energy of a photon equals H times F. Well, F is my frequency. Energy is my E. Okay, so I have a dependent and independent variable. My independent variable, my X, is my frequency. My dependent variable, my Y, is my energy. Now, H is what we call, my man, Planck's constant. So it's just a constant, okay? So if you think about it, this is just the coefficient before my changing frequency, before my X, okay? So frequency is really just an X, or my independent variable. This is just a coefficient that does not change, Planck's constant. So this tells me something important. This is a direct variation. And this tells me as frequency increases, the energy of my photon also increases. So which one is an increasing direct variation graph? Number C. Letter C. I'm a math person, so I say number C. I'm allowed to do that. All right. Next one. Yay, I will be able to prepare for the physics final exam. Woo! Waves 2. Okay. Calculate the wavelength of a photon having 2.51 times 10 to the negative 19 joules of energy. I don't like this. No idea what that is. Okay, back to the same exact equations we were just looking at. Energy of a photon, and I have a wavelength. Okay, wavelength is this little lambda guy. It's like an upside down Y. Okay, I always draw them poorly, so forgive me. So HC over, okay, let's see, let's write this down. Energy equals H. Now H again is our man Planck's constant. I think he probably wants to say Planck. C, if you remember from our friend Albert Einstein, is the speed of light in a vacuum. The cosmic speed limit, so to speak. Over the lambda. Did I draw it the right way? Yes. Okay, which is my wavelength. Okay, so basically, what do I have to do here? Well, I have to solve for lambda. Lambda has to be my final thing here, so how am I going to do this? Well, I hate when this happens this way. Okay, so this is like my least favorite thing to do, especially when it comes up with trigonometry. Trigonometry. Like, I know how to do this, but what happens with me is I'm like, how do I draw it? Because I do this a lot of times in my head, because I just know you can flip things, blah, blah, blah. So this is what I'm going to do. All right, I'm going to multiply this by 1 over HC. This is how I'm doing it. You may have a different approach to doing literal equations. But to me, it's this way. That'll cancel out Planck's constants times speed of light here and here. And here I get divide, so I have E over HC. Now equals 1 over lambda. Now, my cheating math head says just flip both of them. You flip both of them. Some people are going to say you're going to multiply both sides by h and then divide. I'm going to say just flip both of them. Find the inverse of both of them. So HC over E equals lambda, or lambda over 1. See how I draw them backwards? That's the right way. That's the wrong way. But you get what I'm saying. So now I just have to put everything together to figure out lambda. So H, all these constants, of course, on the front of the reference table, Planck gives me 6.63 times 10 to the 34 times 10 to the negative 34. And C gives me roughly 3 times 10 to the 8 over the energy that he talked about is 2.51 times 10 to the negative 19. All right, so you guys know about me, I hate doing this. If I have my graphing calculator, I am plugging this all in and doing it that way. I'm going to do the top half and then divide it by the bottom half. Because I'm lazy right now. I'm going to do it this way. Okay, so let's just do it this way. 10 to the negative 34 times 10 to the 8, doing the exponents first, should give me 10 to the negative 26. Okay. Now, 6.63 times 3 should be somewhere in the range of 19 and a half. I don't know. Let's see where I am. 6.63 times 3. 19.89. Okay. Over 2.51 times 10 to the negative 19. Now, with division of exponents, remember you keep the base and you subtract. So 26 minus negative 19 should be, man, I am burnt today, negative 7. Now, next part here, 19.89 divided by 2.551 gives me 7.92. No need to move over my decimal, so about 7.92. The wavelength, okay, so wavelength is in meters. So there is your wavelength. Of course, it's very small. And if you want to know this color of this photon, what would the color be? 7.92. Well, where it would fall. Oh, it's just off of violet. It's in the ultraviolet. Oh, hold it. Yeah, it's in like the ultraviolet range. 10 to the negative 7. You have to solve a problem like this. You know it's 10 to the negative 7. It's somewhere here. So if anything, it'd be an ultraviolet ray. Interesting. Let's do one more, and then you guys can work on your final in your other class, even though they're not as important as physics, because physics is the universe, and I'm teaching you about the universe. Who cares about everything else? Of light, of wavelength, 3.2 times 10 to the negative 6 meters, consists of photons having an energy of. Didn't we just do this? Okay. So, again, we're going to do E equals hc over lambda. So, negative 6 isn't curious. I wonder what is this? This negative 10 to the negative 6, where does that put us? What type of light is that? Ooh. Might be actually... We'd have to figure out the frequency, but could actually be in the visible light spectrum, actually. But I can't figure that out right now. It's too close to call. All right, so here we go. H. Planck's constant. I mean, this is so annoying. All right, so. But, again, when we're taking this, we have all the time in the world. 6.63 times 10 to the negative 34 times speed of light, 3 times 10 to the 8, all over 3.2 times 10 to the negative 6. All right, so I add these up. Remember we said before you get 10 to the negative 6, negative 26, 6.3 times 3, we figured out last time. This is nice that we got this, is 19.89 all over 3.2 times 10 to the negative 6. We do these when you're dividing exponents, you keep the base and subtract the exponents. Negative 26 minus negative 6 is positive 6 is minus 20. Remember, this is going to be in joules too. Equals, times. Now 19.89 divided by 3.2 is 6.21. So 6.21 times 10 to the negative 20 joules, very little bit of energy. I mean, it's just a photon. 6.21 times 10 to the negative 20 joules. Interesting. All right, guys. I'm not going to make you do much more today. I'll talk to you tomorrow. Good work. There's my work. Speaking of good work, there's my work. Okay. Keep in mind, these are the two. This one and these are the ones what we focused on today. Basically the same equation, just knowing that we have that speed of light throw in there, and the inverse of the frequency is the wavelength. Have a good one, guys. I'll talk to you later.